Okay? Hi everybody, this is lecture 29. We're discussing section 4.6, which is Newton's method. Newton's method is a technique for finding an approximate value for a root of a function. So remember that a root of f of x is an x value. Such that if you use that value as the x, the resulting y value is 0. So for instance, that would look like this. So a point on the graph would be r comma 0. Now sometimes you can solve an equation to find the value of r. We do this all the time. We look for x-intercepts on a graph of a function by setting y equal to 0 and solving for x. And even the function that you're going to be dealing with in your handout f of x equals x cubed minus x squared minus 3 has roots r equals square root of 3 and r equals minus square root of 3. And this is roughly 1.732. So we actually have a symbol for the root. We know how to solve an equation to get us a root. But there are a lot of functions where you can't solve an equation to get a value. And also, you know, how do I know that? I've just got that memorized. So if you wanted to come up with a decimal approximation for square root of 3, how would you do it? Well, Newton's method is one way to do it. And so you're going to see that what it amounts to is you guess a value of x, an initial value of x that you think maybe that's the root. And what can you do? Well, you check. You put that into the function and you see if you get a y value that's 0. If you're lucky and you do, then you're done. You found a root. But if that guess is no good, what's a good way to get a smart second guess? And then test that one. If that is a root, then you're done. If not, can you make a third guess? So that's the process you're working on now. Now, as I mentioned before, these kinds of handouts that we work on in class are always on the course webpage. So, for instance, today's worksheet is there. You could download this onto your iPad and you could write on that PDF. There's also a similar worksheet if you have so much fun that you want to do another one of these. There's another worksheet, a little bit harder function. The worksheet that you're doing, again, we already know a symbol for the root. It's square root of 3. But this worksheet number 2 is a function where we don't have you don't know a technique for finding a symbol for the root. All right, so I'm going to shut up and let you work on this on your own, and I'll talk to you again in a little bit. Who just came in? So why don't you sit with them? I'll give you I think, Gabriel, you can go ahead and turn that off and we'll just resume later. Draw your attention again to the web page. You know, you can download this worksheet. There's another worksheet. Thing is, there's a whole section of the book that's Newton's method. So, and you've got some homework problems in that section. Now, in those homework problems, you won't have worksheets like this. So the idea of this worksheet is it's training you for how to solve a Newton's method problem. And so do this worksheet, do that worksheet as well, and do your homework problems. Because again, you've got homework problems on Newton's method. And so it's a topic in the course. So it'll show up on quizzes or exams or the final or all three. So make sure you practice this. Now let's look at this together. Cameron, why don't you come grab a handout here. So, on the count of 3, what is the slope of that line? 1, 2, 3. B over A, rise over run. All right. If you solve that equation for A in terms of B, how does it go? Ready? 1, 2, 3. B over M. Good. Now, how tall is the right leg of that triangle? Yeah, because this x-coordinate is x1. That's a point on the graph, so that means the height of that point is f of x1. So that point has coordinates. x1 is the x-coordinate, and f of x1 is the y-coordinate, so the height of that point is f of x1. Okay, question D. What's the answer? What's the formula for the slope, or what's the expression for the slope of that tangent line? F prime at x1. Yeah, good. Now, so then what is this delta x then? Somebody else, who can tell me what an expression would be for that delta x? Marie, I thought you were going to raise your hand. You sort of did. Jonah?
Is it b over f prime of x1?
What about what's b? So we already know it's b over m, but b is the height of that point.
Oh, it's
So that's f of x1, and then the slope is f prime at x1. So what's the formula for x2 then? If we know the coordinate x1 and we know this distance, delta x, what's going to be the formula for x2? Yeah.
X minus f of x of 1 over f prime of x of 1.
Yeah, it's going to be x1 minus that stuff. Now, the thing is, notice in this picture, x1 is not a root because the y value there is not 0. So we want to go fishing for another x value that might be the root or might be closer to the root. Notice this x2 is a little bit better because the y value there, well, it's still not 0, but it's not quite as high. Now, what if x1 had actually been a root? What if you made a first guess and it turns out it was a great guess? I just found the x value that's a root. Well, then f of x1 would be 0 in this formula, and so the Newton's method would say, stop, you're done. X2 is going to be the same as x1. You don't need to do any more guesses. All right, now, let's go work on this table. F of x is x squared minus 3. Now we already know that a root is, the actual root is square root of 3, which is about 1.732. But we're going to see if we can come up with an approximation for that. So first of all, we have to get f prime. F prime is 2x. Now we have to just get to work building this table. We start with initial guess of x1 equals 3. So f of x1 is going to be x1 squared minus 3. So that's going to be 3 squared minus 3. So that's going to be 6. So a 6 goes there. F prime at x1 is going to be 2 times x1 using the formula for f prime. So that's going to be 2 times 3. So that's also 6. So a 6 goes here. So to get x2, I do x1 minus f of x1 over f prime at x1. So 3 minus 6 over 6. So that's the number 2. So a 2 goes here. So we've got our second guess. We guessed x equals 3. That's not a root. So our next guess is going to be the number 2. So the number 2 goes here, and we start the process all over again. So f at x2 is going to be 2 squared minus 3, so that's going to be the number 1. So a 1 goes there. Okay, f prime at x2 is going to be 2 times the number 2, so that's going to be the number 4. So that goes here. So x3 is going to be x2 minus f of x2 over f prime at x2. So that's going to be 2 minus 1/4. So that's 7/4. Hey, what's a decimal for 7/4? 1.75, which is pretty darn close to 1.732. Isn't that cool? We've already got a pretty good approximation. In fact, that's where I'm going to stop, because So there's my my x3. Now I want to plot these points. Now if you follow these instructions, I've got to plot x1, 0, which is 3, 0. That was our first guess. Now that's not a root because its y value turns out to be way up there. This is the point 3, 6. So then we use the process to get our next x value, which is x2 is the number 2. And so we're supposed to plot 2, 0. And we're supposed to draw this segment. I'm going to draw this segment in green. The fact that that green segment is not of 0 height, that's because the number 3 is not a root. If the number 3 was a root, there'd be an x-intercept there. Now we're supposed to draw the segment that connects these 2 points. I'm drawing it in red because it's a tangent line. It's the line that's tangent to the graph. So since this point was not a root, the method says basically follow the tangent line down, and that's going to land you at a better place. And so then we check, and well, okay, this is also not a root because the y value here, oops, shoot, I didn't do a good job there. This point is supposed to be over here. Ignore that one. Bad Dobby. So 2, 0 is supposed to be there. So is 2 a root? Well, let's check. The y value at 2 is 1. It's not 0. So the method says, okay, we'll do that process again and get x3. x3 is 1.75, which is right here, 1.750. Notice there's my line, which turns out to be a tangent line. So our third guess is pretty darn good. The actual value is about 1.732, and after only an initial guess, a second guess, and a third guess, we've gotten that close. And again, that's not actually a root, because you can see the y value is not actually 0, but you see how this method works. All right, let's put everything away and do our quiz. If you would, please sit in alternate seats. Thank you all.
Every time we